Hi, everyone, and welcome to the Information Bottleneck podcast, the podcast that squeeze out all the relevant information. And today we are happy to host, if you want, a very special guest, Ariel Noyman. He's a research scientist at MIT Media Lab and an expert in urban design. Hi, Ariel. Welcome.
Hey, thanks for having me.
Okay, so hi, Ellen, also.
Good to see you both, and good to meet you, Ariel.
Nice to meet you, Alan.
And as always, we will start with some news from the recent days. And maybe the most interesting one is a new report from Anthropic about cloud usage. And they show that most of the users are using cloud for both coding and math, something like 36% of the conversations. And then 12% is teaching. And I think this is very interesting because like it looks that at the beginning it was something that like most of the people use it for like again for coding or like asking very simple questions, and it looked at it become like these models became very good in teaching. And probably right now there are like I don't know hundreds of startups that are trying to use models, LLMs for teaching in different settings, in different aspects, and probably it will change the world and it will change how we teach everywhere.
Yeah,
And
I'll just mention that I think Anthropic being seen as the code model, like the Claude series, was really heavily powered by its defaults in Cursor, and I think a few like maybe Windsurf as well for a while. And those defaults have rapidly changed with the wind. But right now, Claude is in a really nice spot where OpenAI's ChatGPT-5, by using a model router, has really lost trust with a lot of developers who are like, no, I want to exactly know where my that it's going to go to the biggest and best model when I write a query, even if it seems so-called, simple. Especially when you look at their data cutoff point in comparison to GPT-5, which I think took a step backwards compared to some of the previous GPT 4.1 or 4.5. I remember being shocked at that point too. Claude's in a really good position and really just has to compete against Gemini here for code, with the exception, of course, of Codex, which we'll talk about a little later.
yeah, Codex, I think like they just released OpenAI just released a new Codex, GPT-5 Codex, and I must say that it looks really good. I think if before Cloud CLI was much better and was in another different level, now Codex is really good. Like you can give him so many tasks in so many broad different aspects and just figure it out. Like you don't need all these intermediate, yeah, let's write it to this file, right? Like, let's write like your plan to this file and then let's change the plan and let's change this file and what is exactly your context, like all these intermediate steps that we did before with Claude. Right now this is my default AI coding tool.
And well, I was just going to ask because I'm still behind the times and I still mostly use Cursor. And I find I have a very limited amount of like Cursor agent stuff from my company, so I run out of it quickly because I'm always using it in max mode. So I don't. I guess my question then is also somebody who's only barely used Claude code a little bit. I remember you talking about the like parallel agents hierarchical kind of execution thing. But what specifically about Codex now? Is it just like this new model, right? The fine-tuned model that came out with it? Because and then how good really is it? Because the way what I'm doing now is I have this like old roguelike game that I'm not willing to go like properly learn all the library and stuff for, but it's like I have good ideas and enough to go slightly more than vibe coding here, like to actually audit the I want to make my dang game, so let's get this done. Like I'm ready. Come on,
Yeah, it's a good question. I think like for me, it's much better for coding, like for day-to-day coding. I think this is much better. It's much more efficient. You don't need to explain it again and again. It doesn't stuck in weird loops, all these things. Again, it's not perfect, of course, but for when you have, I don't know, a large enough context, much better.
Well, and the request, like, is it expensive or
Yes.
you?
It's probably like hopefully like someone else will pay on it. You need to ask from someone to pay. It's very expensive, but that's life. And we are in America, right? Like you need to pay on good things.
Are you using any of these tools, Ariel, in your day to day yet?
Yeah, I think you touched on an important point. What is your company paying for, and then what can you use? So in my case, I do have full access to the Copilot suite, which I have to say is moving very fast. The amount of changes, literally, sometimes a few times a day, I see the package updating, and then you have a new model you can use, or you have a new process you can utilize, and that works very well. I was excited by Claude Code, and I wanted to see how it works. I don't have access to Claude, so I got the Open Code, which is the open source version of a similar kind of process, nicely integrating in VS Code, and then you can choose from many different models. I think Grok was for a second free. Like there was a few days where they put it out there free, and then you could use it there, and it was actually performing pretty well. So I ran not a super complicated task, but it did gather the fairly large code base and a big context, managed to operate within it and create some, I think, interesting adjustments. I also tried that with GPT-5 and with Gemini. Gemini is almost always my go-to model for these tasks. But generally, yeah, I haven't used Claude that much, but VS Code is a good uprunner.
And it's interesting because like we are AI researchers. At the end, we are trying to develop better models and things like that. But I think it would be interesting to hear your point about these models, right? That like there is like a new model every week, and are you, I don't know, excited to use it, or like does it help you by a lot every time there is a much better model?
Yeah, maybe in the half an hour we're spending here, there are 5 new models that came out, and we're just missing them somewhere in the Twitter feed. I stopped being excited by new models. The 2.6 of a 2.5 doesn't really excite me anymore. Nevertheless, I think as soon as you start to see real users, hardcore users, not just kind of the vibe coders out there, but real users starting to show, hey, this model actually performs much better when it comes to coding, or for this type of coding versus the other type of coding, or this model is better for, I don't know, image generation, which is a big part of what I'm dealing with, for 3D generation, which is up and coming right now. Then definitely I would jump in and test it. But again, I think I became a bit more cautious about what is really exciting and what just looks very good on paper or maybe in the evaluations. But we all know that these evaluations are somewhat questionable.
Yeah, it's a good transition because I wanted to talk about a very nice evaluation framework that I found. Alex Daimakis on Twitter just shared a good takeaway, I think. He talked about a evaluation framework that called the Terminal Bench, and this is basically it's a framework that you need. You have some files, Docker files, that you need for setup. You need to like the files themselves are broken. Something in their environment is missing, and then you need to say the task is there is something wrong with my Python environment. I can't install this and this package. What I should do? The way and the model needs to understand what is wrong with that. And I think so. This is evaluation framework, and I think there is a close connection between this and RL environments. And actually, we can use these evaluation in order to make better and better training environments and to get our models better and better. I think this connection is we need better environments in order to get better evaluation. All these LLMs as a judge and like very complicated if you want simulation that you can actually get a good evaluation in different settings, but also the other way, if you have good evaluation frameworks, you can actually use them as RL environments. And I think this combination of mixing can give us much better. models and the training pipelines. Okay. So yeah, what else?
Well,
Maybe yeah.
sorry, I was thinking about the whole terminal bench process. I think that, this all goes back to verifiable rewards too, right? Around you start integrating some of this into models, like coding models. Maybe that's some of what the Codex models had, right? And benchmarks like this seem to be very in that wheelhouse. Sorry to interrupt.
No, yeah, I think I agree. Like at the end, RL, it's something that at the end you can use it for everywhere. You just need verified rewards. You just need something that you can verify, and that's it. It doesn't really matter what is the specific example and what is the specific signal. You have a verifier, boom. You have a training RL framework, and I think we will see it. We already started see it in the recent months, but I think it will be much, much more dominant in the, say, next year or something like that.
Well, and we have the NeurIPS, I think, release of results in a day or two, right? So we might just see a whole bunch of new papers and announcements and everything.
Yes. Do you have also like this? So I know in computer science, it's crazy these days. Like you have these 3 or 4 main conferences, and you have this, like you have the deadline, and before the deadline, it's totally crazy. Like people are working days, nights, whatever, so many hours, and everything just so stochastic. Like the paper can totally change in the last 2 days. Is it true also
I was
in your
about to ask
field?
if you guys have betting markets on who is going to get how many papers. That can be an interesting way of funding your trip to wherever your IPS is taking place this year.
Yeah, it can be nice
Can be.
to get
I
money
love
out of this storm.
tiring process. I love to read the feed after you get the results, and then you see the kind of reactions from the reviewers, and some of them are really funny. And so I kind of follow that over the past few years. Urbanism is a slow moving profession, and for that reason, if you release a paper today or tomorrow, I guess the city is not going to completely shift and change. Although some topics, when they become extremely popular and relevant, there is some, I guess, kind of a chasing of who is publishing it first and what's more relevant. In the past few years, you had topics like smart cities and digital twins, and even AI for urbanism was kind of a big thing a couple of years ago. So I guess there was some degree of urgency, but I don't think it's anywhere remotely close to, publishing a paper when every 20 minutes you have a new model or a new technology coming out, and you might already be too late.
But do you see, so like in computer science, everyone are trying to do AI and machine learning, of course, these days. Do you see this shift also in urban design? Like people try to do more AI all the time?
I think we see quite a lot of people trying the tools, playing with them, mostly, of course, as users. I don't see a lot of people training their own AI models for the usage of cities, although some of them do. I think there is a general trend of testing new technologies, usually with a lot of suspicion. That's something that is inherent in that profession. And I think it comes from actually from a good standpoint. As I mentioned before, cities are built for a long time, right? If you build a building, it might be there for 80, 100 years. If you change the road, it might be there forever for the lifespan of a city. The last thing you want to do is to do it quickly, dirty, and inaccurate. So actually spending more time and thinking more deeply about your decisions, about what you do, is a virtue in this profession. Saying that, it doesn't mean we shouldn't use technology to improve Excel and make these processes better. So if there is something mundane, slow, bureaucratic that you can excel using technology in general and AI models for sure, definitely you'll see some of that happening. I think that since the recent models became more visual, and by visual, I'm reflecting, on images, on 3D models, on world models, three-dimensional kind of interactable models. I think I saw more and more interest in our field to kind of say, hey, maybe we can use that for our own immediate needs.
So I have so many, maybe Ravid, I don't know if we have like more news, but I am totally fine with getting into kind of talking about urbanism and relate, AI with Ariel.
Let's
All
do
right,
it.
so
Let's
okay,
do
let's
it.
cool. All right. Let's start. So Ariel, I should also give a little background about my connection to urbanism. I like cars, but I also like, walking and bicycling. And I live in Portland, Oregon, which is a pretty progressive place in even in urbanism, right? In design, especially of the city core, quite walkable for how sprawling it is, I would say. Also, when I did competitive speech and debate back at my closest, like best accolade from high school, my junior year, was on the transportation infrastructure topic, where I argued on the affirmative every time for building more mass transit, which we defined as buses, subways, and light rail, very, very clearly, and maybe ferries, depending on who the judge was. So I read a lot about this. I know a lot about like circa 2013 evidence around, and I remember complete streets was a big deal around then. I don't know if you've probably heard that term, right? So I'm very curious about what shift has there been more on the urbanism side, right? I think we can talk about the AI right after, but just on like urbanism in the past 10 years from the academic study of it. And I would even say I especially care about things like traffic management.
I think one interesting thing that happened was the short life and death of smart cities was a big thing that might have happened. There was this big. I'm coming from a background in brick and mortar architecture and design, like kind of the historical hardcore building of buildings, hard hats, construction sites. And then a decade ago, when I joined MIT, the one thing that brought me to the Media Lab was a course called Beyond Smart Cities. Now, that was the first time I heard the term smart cities, so I didn't know why we need to go beyond them so quickly. But what I learned very quickly in that course, which eventually ended up being my work now at the Media Lab, was that the interest in technology was, I think, misguided in the early days of the smart cities movement, and that a lot of interest with how algorithms can potentially, you mentioned traffic, control our traffic systems, create ICT mechanisms that allow us to sit in a room and control the entire city from a dashboard, and all of these images of early 2000s city management techniques kind of failed and weren't really successful in creating the desired outcome, which I think you were mentioning about, walkable cities, accessible cities, highly dense, vibrant environments. All of that was not there. These were sort of top-down mechanized systems that were supposed to be optimized the same way that you would optimize a technological system, only that there are people involved. And as soon as you introduce humans into the mix, that city is not a simple system, but a system of systems, which is extremely complicated, hard to manage and control. And in that sense, move away from pure technological perception. So I think the decline of the smart city is something very noticeable. And in the history of cities, it will be remembered as kind of a footnote.
So, but let's go just a second, Ellen. Like, let's go a step back and let's explain us what does it mean even like urban design and what you are trying to do.
Awesome. So as I mentioned, I'm coming from this world and then transitioned more into the technology side. I think very broadly, there are basically three major, let's say, professions. You've got the architecture, which will be mostly within the building scale, the building itself, somewhat of its context, but the building. Then you would have urban design, which is what happens between the buildings. So a building, a street, a sidewalk, a bike lane, all of that will be usually handled through urban design. Also small parks, pocket parks, city parks, things like that. And then you have the urban planning and geographical scale, which goes through the entire city and then also for the regional and out of city areas. So urban design would be really that world of between the buildings and what happens in our street, which is what we, I think, as people living in cities experience day in and day out.
So I played this, and you might know about these video games from a little while ago that Ubisoft made.
SimCity.
Well, I played. We could talk about SimCity as well. I love
sure.
SimCity 3000, but I was about to say Watch Dogs, and I don't know if you've heard of it, but the whole premise, especially of the first game, is that the smart city movement really took off. And suddenly all of like it's like, I think, AI system of like what 2013 people thought AI would be, kind of controlling cities, and this like elite hacker guy who's like hacking all the city infrastructure to kind of get around. It's like a Grand Theft Auto kind of gameplay. I was just curious though, because a big part of that was like the privacy and security and surveillance implications of a fully executed smart city. Was that part of why the movement died? Was any of those three things?
A huge pushback around that movement was related to privacy and safety. The fact that you can track people, understand what they do day in and day out, really at very high resolution, was definitely frightening. But I would argue that you still have many, many very successful, S&P companies that are making a lot of money from tracking people. So that probably was not the only deterrent. It was probably one of the kind of red flags, but the fact that the systems were not actually operating in the optimal way, as you would imagine them working probably in these movies from, the early 2000s, I think in some way kind of convinced everyone that we have to take a different approach to cities and understand them much more, I would say, from the pedestrian point of view, from the person point of view, instead of looking at them as a system. I'm always quoting, there was a seminal paper, I think it was by IBM, but maybe I'm wrong, that was defining the term smart cities. And in that paper, they were trying to talk about what are the different urban systems we can potentially improve and excel through technology. So we're talking about sewage and water and energy, and then they get to people system. That's how they define it, right? And I think, it's like if you would ask Data from Star Trek, how you define people, it's people system, right? It's like another system in my ecosystem that I have to control. I think that as soon as you have that perspective over cities, you probably already failed, because it's going to be very hard for you to look into that very fluidic, very kind of biologically moving system as another technological system you can control. So to me, that would be kind of the major reason why this movement failed.
So what do you think is the right perspective to look on cities?
So I'm always trying to define it from smart cities to street knowledge. I'm calling it street knowledge. Some people might remember that as a quote from a song, which I'm not going to repeat because it's probably illegal in many different broadcasting services. But street knowledge for me would be bringing the two together. So bringing the technological layer that can help us understand what happens in the city, but positioning it, framing it from the point of view of the individual in the street, in the building, in kind of the human scale. The reason I think this is an important transition is because looking at cities, again, from above, kind of the 20,000 feet above, and trying to understand them might work for some systems. And therefore, since the 1960s, we might be able to model traffic because it's kind of a closed loop system in cities. It's not easy, but it's pretty kind of graspable. There are clear limits. Same goes to maybe gas and water and some energy systems that you can probably map out. When it comes to human behavior and experience and movement, human movement, not vehicle movement, this becomes much more complicated. However, we do see some interesting technologies in the past few years that help us to better understand that kind of intersection of people and cities. And I think that this should be kind of the focus of what we do as we.
I'm just curious. I was just in Houston, Texas, which is one of the more interesting places in America and probably the world from a urbanism perspective, right? Namely, their complete or near lack of zoning laws, de facto, certainly the least zoning restrictive place in probably America that's like a major city. And if for anybody who's seen that movie Up, the situation of that like little house in between the like giant skyscraper and parking garage, that happens. I see that all the time in Houston, right?
Or below a power line.
Yeah. I've always been curious as to what do people in the urbanism world think of Houston in particular, and also, can you imagine if a place in maybe a progressive part of the world that did care? So, for example, Oregon, Colorado, New York, Vermont. Like, what if any of them did this whole let anybody build anywhere? Because this is what I claim the YIMBY, right? The opposite of the NIMBY people kind of want is what Houston has, right? So I'm curious as to your thoughts on this whole thing and maybe how AI relates to these questions of like zoning.
It's funny because you're tapping on an extremely relevant question that is really taking off today. I would put two buckets here. One is the abundance people, and the other one is the Doge people, and I'll explain. So Abundance is a book that came out last year and made a lot of waves in the, I think, democratic side of the map, liberal side of the map, liberal cities, progressive cities, where for the first time, those questions were truly asked. Why is it that we cannot build anything? Why is it that we are so slow at implementing any type of infrastructural change or even just erecting new building, new residential building in San Francisco, in New York, in Boston, places like that? Where in places like Houston, you can practically build whatever you want wherever you want. Of course, there are downsides to that. You might find a house under a highway or a power line. In time, people are reasonable and might make good decisions by themselves, and therefore you see, for example, sharp decline in the rent and the purchasing cost of houses in these areas of the U.S. Where in the coast areas, New York, again, San Francisco, it's impossible to buy a house or even pay the rent. And so that would be sort of the abundance side, and the book kind of created a lot of traction. At the other side, there is the Doge people, which over the past couple of years, we're talking about eliminating basically every kind of regulation or removing a lot of them in a pretty harsh way. So like, completely cut zoning out, completely cut regulation out, and expedite all the processes. It's kind of the horseshoe theory, right? These two are coming from both different ends, but they meet at some point. And the point, I think, where they meet is that everybody agreed that the processes are not optimal. And, the funny thing is, for the past 10 years exactly, I've been showing a slide at the beginning of each one of my talks. Now we're in an auditory medium, but the slide would show basically 3 books: a very narrow book from 1946, wider book from the 1970, and 12 binders from 2011. These are the zoning books of LA. Okay, 1946, you could read that on one subway ride. In 2011, you cannot even capture the 11, binders in one photograph. And this is kind of, I think, a visual, physical representation of where we are. We created huge amount of complexity, huge amount of paperwork. And for that reason, I think we're struggling with making anything built or being able to kind of move forward many of the very necessary infrastructural projects we have. Your last part was, how can we involve technology in that? And so, I think there are basically 2 main categories here. One is just take the 11 binders out and throw them into an LLM and make good use of them. But this is a bit like building a hospital next to a crumbling bridge, right? So you solve the problem, but you haven't really solved the core of the problem. Right? You still create tons of zoning, you still create tons of regulation. You just fix it through another, tons of GPUs somewhere else. I think a more kind of fundamental change, a more fundamental fix might be by introducing technology earlier in the process, meaning rethinking the entire idea of what is zoning, what it's meant to do, how it improves or excel or changes our cities. And then when you go back to those questions, you might define a much more fluidic, much more systematic, and probably technology-driven zoning mechanism that can update and change itself with the needs of the city. Not once every 20 years, not through 4,000 or 5,000 pages books, but really through a system that kind of listens to the city in real time and then report back with the needed zoning or changes.
But I have a question, Ariel. So, like, do we have some metrics that we say actually, okay, this is a good city and this is a bad city, or like, how can you actually measure it?
So I always try to avoid those metrics. You usually see them on, cheap flight magazines where, the best city for X, the worst city for Y. These criteria usually tend to be irrelevant. A city is an agglomeration. Every modern city, I would say, historical cities might have been small, but every modern city is an agglomeration of many neighborhoods and many pockets. Each one of them could be great or not. And so I think our criteria, first of all, should be about kind of the neighborhood scale, up to 100,000 people in most cases, sometimes even less than that. This would be defined as city. And historically, if you look at cities, that was their scale. If you think about it in spatial terms, 0.5 mile to 1 mile radius, no more than that. Afterwards, it's really becoming kind of a metropolitan or kind of a larger city. So that's to begin with. And definitely there are criteria and metrics and KPIs we can measure. Of course, not all of them are completely, I would say, linear. Meaning you do X, you get a great city. Some of them are a bit more convoluted and complicated. But the more simple ones would be, first of all, accessibility. So how accessible are your POIs, places where you work, places where you live, and kind of the mix of functions and amenities within your built environment. That's a critical aspect. The other one would be how mixed the neighborhood might be or the city might be. So do you see people from different demographics, from different backgrounds, from different professions? And I think that if you go and look into all the cities that are considered to be successful, you would find that, if you're in Rome or Barcelona or Paris or New York or Berlin or Shanghai, it doesn't matter. They all have those criteria, maybe in different factions, maybe visually they look different, but you would find much of that accessibility mixing as a critical aspect of those cities.
Okay, I think it's a great time to move to talk about virtual environments and how actually we can make digital replications of urban environments, right? And like maybe to try to calculate and to measure these metrics. So yeah, tell us how can we make virtual environments for urban designs?
So I started by telling you that I began my
Why to
career
do
as
it?
a yeah. I started by telling you that I started my career as a designer, as an architect. But over the past decade, I work at MIT on building urban modeling and simulation platforms. And the goal of these tools is to help cities, exactly following the conversation we just had, to improve their processes. So how can we take a process that is challenging, that is slow, that is bureaucratic, and make it better through modeling and simulation tools we're building? We usually try to cluster this work through 4 categories. We look into what's currently happening in the city. We call it insight. So what is the data we can currently gather and understand the current state of the city? Then we look into transformation. How do we move from where we are facing the challenges to where we might want to be? So building iterative, collaborative tools to do that change. Then we look into prediction. And prediction would be the implicit, more subtle cues that those changes might have on the city. So how would that impact the way we move in the city? How would that impact the way we experience the city as we move through it? And finally, we pack all of that into consensus. So how do we bring that into a kind of an agreement process? The paper we're talking about today falls nicely into the third category, which is understanding the more implicit aspects of change to the built environment. What is the sensation, the experience of traversing through a place?
And just why to do it? Like why we should care about it and who should care about it?
So every time we build something in the city, the goal of a designer, of a planner, of an architect, of an urban planner is to understand what will be the impact of that change. We hire an architect to design our home. We want the architect to know very well how we're going to use the home. We don't want the kitchen to be far away from the dining table because that's not an efficient design. Same goes to urban design or planning. If we design a park which is far from where people might use it, then the park is kind of useless. Walks that are unusable for whatever reason, or a bike lane that is disconnected in many places, it's not a usable bike lane. So all of these questions are part of what we would call a prediction. Right? We're trying as designers to predict the future of our city and how it's going to be used. Now, for many, many years, I would say almost half a century, we have tools to make some degree of simulation in the built environment. Traditionally, this falls under a category called agent-based simulation. These are not our new and fancy agents. These are kind of 1990s agents where you would create a computational entity that moved through the built environment and give you some information about that movement. For example, you design an airport, which is a very typical complicated build. It's very hard for the design team to analyze how people would go through that building. They might understand how an individual, one person, would go from the parking lot all the way to the plane. But what happens when you have 10,000 of them, right? And some of them are employees and some of them are visitors, and you want to understand all of that system at once. So you run an ABM, you run a simulation on that building, and you start to see bottlenecks, start to see the hotspots where there is a kind of a human congestion happening at which point, at which part of the building. Another example would be taking a stadium and using it to simulate emergency. What happens when there is a fire or there is a storm and you have to evacuate everyone? So you run a simulation, all the agents are kind of scrambling around and some of them fall and some of them trip. And you can actually make very, very complicated simulations that way and show what are the challenging points. All of that was great. The one thing we were trying to ask ourselves with this paper is, what happens if I want to interview one of these agents? What happens if I want to understand what was their experience while moving through the space, and not just in an emergency, but just in a common day? You wake up, you go to work, you walk through a street I just designed. Would you like it or not? Does it serve your purpose? Can you have an easy pathfinding, wayfinding in that environment? Would you sit down in that park, or would you just cross quickly because you feel intimidated and afraid after hours? So all of these questions were something we wanted to answer. And when we did our literature review, it was very clear that very few people are working on that because it's fairly impossible. When you think about how you want to implement something like that, you can do one of two things. You can either build it, run people through it, and then test, but there is no A/B testing in urban planning. You cannot, first build it and then demolish it and build again appropriately. You can build simulated environments and use VR or AR to kind of test how people might react. But this is a very costly type of experiment. You're going to have many, many people using many, many hours of VR to give you a lot of input. Or you can try ABMs, you can try simulations. The problem with simulation up until very recently was that those agents were not able to speak. They were not able to talk. But that all changed about 2.5 years ago.
And okay, so now you want to build a simulation and you want to use the recent models to do it. And I don't know, like I see so many difficult questions that you need to address, right? And how you start to build such a simulation?
So I was on a flight to Chile and read Park's paper from Stanford about generative agents, and kind of a light bulb came up above my head, and I realized I have to try that. So to those of you, I guess some of you know that, but Park and his team worked on building, I think, the first real proof of sort of community that was generated through generative agents. They were running those LLM agents in a city. I think they call it Smallville or something like that. It was a cute, tiny city, which became, by the way, the graphic design of every multi-agent paper afterwards, those tiny pixelated nice agents. And those agents had what we call in ABM an emergent behavior, meaning they were interacting in a way that was not just realistic, but also kind of self-growing or kind of interesting over time. One of the examples I always like to talk about is that one of the agents there was planning, I think, a Halloween party or something like that. And I think it was she was talking to other agents in the city. Some of them just say, thank you, I might show up. Others actually spread the word, and the word kind of spread in the city. And some of them were coming back to help her organizing it and doing all of that. When we think about agentic systems, this didn't exist before agent had that ability to communicate and kind of move forward beyond the heuristics, beyond the initial rules that agents were set with. Agent-based simulations that I mentioned before, the ones we might use in an airport, have very, very strict rules. They probably follow a path, they follow the shortest path algorithm or something like that. They have some randomness into their behavior, but all of that is usually very, very fixed. It's very clear. These agents in Park's paper were completely open. They had some environment, but they could do very, very interesting things within that environment, almost limitless. And so for us, that was kind of the initial idea. How can we take that, but from a simulated city to kind of a more real city, a real environment?
How you check, right? Like there is one thing to say, okay, so like we have some anecdotal cases that, yeah, it says hi or thank you, to something that behaves as humans, right? Like how you actually quantify it and try to measure the biases and things like that.
Yeah, that's an awesome question. So one thing we had to do, first of all, is to move the agent from this sort of fictional LLM world into a physical world. So we build very simple three-dimensional environments, just a basically 3D model. And then we used another generative model, image generation model, to take those models and create realistically looking street view images. So imagine Google Street View, but instead of a real environment, a fictional environment that we are creating and feeding it back into the agent. And the agent looks into the world the same way that a first-person game or shooter would look at the world, basically walking through that fictional environment and making decisions based on where they want to go. I go forward for 10 meters, I turn left, etc. What we then did was to ask the agent to report back in each one of the steps about what they have experienced, what they have seen, and why they made a decision to do whatever they've done. And we ran hundreds of thousands of simulations like that. So basically, the agent moves forward, then reports back, move forward, then reports back, and have some sort of a very high-level task that they need to complete, but the task was not the most critical thing here. The idea was to kind of gain as much insight from the agent. And so in terms of kind of mitigating bias, first of all, running many, many different simulations and kind of getting, let's say, sort of the equilibrium of all those agent responses together. The other thing was to use many different agent archetypes. So instead of just using, one person or one kind of arbitrary agent, We tried, an older person with vision impairment. We tried a younger person. We tried a male, a female, to see whether we get intrinsic biases within the models. The last thing I would say is that, we're still based on traditional LLMs. So in a way, if there is a, built-in bias in the LLM training, we cannot necessarily avoid that. But like any other models, like the ones we talked about earlier, we can switch between Gemini to and then test what would be the results there.
Yeah, it's very cool. I just saw a paper that look on the bias. They gave agents to play it's called ultimatum game. You know that like you have $10 and you need to split this money, and you can accept or reject someone offer. That like it offers you to accept, I don't know, $2 from the tens. You need to decide if to take it or not. And humans, of course, most of the time are biased. They are not taking it, even if it means that they will not get anything. And apparently, LLMs are unbiased, right? Like they are much more rational than us, and they will take anything that you will give them, and they try to fix it. So we have this misalignment between humans and LLMs behavior, and they had this very clever idea. Instead of like saying to the LLMs, right, be more human, they used behavioral data from, I think, I don't know, 10,000 people survey that they ask people like from 21 different economic tests, right? Like risk aversions, fairness, preferences, all these things. So they just given they condition the agent on one of these persons, right? So they basically insert to the prompt, you're now human with this and these preferences and this test results. And then apparently it become much more aligned. Like the behavior of the LLMs became much more aligned with humans.
You're touching on a super important point. The one thing I haven't mentioned was that the kind of the next step for a travel agent is actually human evaluation, reinforcement learning from human feedback, if you will, but in our kind of simpler version of it, where we build two parallel platforms. One is the travel agent platform where the agents run the simulation by themselves, and another one where we let people, real humans, to run in the same virtual environment and report back on what they have sensed. And in a way, we want to do that, I think, similar comparative study where we show that potentially people, real people, reflect similarly to the way the agent behaves. So in a way that might be, one way of validating our research. Another point that I would mention is that we used a chain of thought process within the model, and the reason we wanted to use that is to basically crunch the information that the agent is producing in each one of the steps. So we didn't want to just create a kind of a long context window where we just take this whole piece of text and then feed it back into our analysis module, but we wanted all the text to be churned with each step so that we, to some degree, avoid those kind of, if the agent started with some perception, that perception would follow through the entire simulation. We wanted that to be kind of shifted and skewed. And we saw that as soon as we introduced the COT, the model response was a bit more reasonable. Again, not necessarily human, but made, I think, more well thought through decisions.
And how sensitive is it to the different, I don't know, model types, or like the level of like the performance of the models themselves? Did you find it? It's I don't know, very sensitive to Gemini versus OpenAI or something like that?
There is definitely sensitivity to the model and, of course, to the initial prompts. Whatever you start with, kind of follow it through the simulation. I do think that the COT helped. So the fact that we introduced the framework kind of reduced some of that cognitive potential bias. I would say that generally we didn't care so much about every single phrase or every single word that the agent eventually reply. So what we do is we take this corpus of text, and it's hundreds of sometimes thousands of words for each one of the simulations, and we try for each step to kind of first of all understand what was the general sentiment. Was the agent confused? Was the agent happy? Was the agent unhappy for whatever reason? And this is something that I think in most model would be the same. So if the agent is lost, it's lost. It doesn't really matter how they pronounce that, but they're lost. And then when we take this whole kind of simulation at once and look at the whole process in one view, I think we haven't seen tremendous differences between the different models. But definitely that's something we're going to have to test. I need to kind of highlight one thing. We take an image, which is what the agent is seeing, and we translate that into text, right? So this is already by itself a challenge because the LLM model we used to infer what the agent experienced doesn't see the world, it sees a representation in text of that world. So to some degree, I think the biggest bias actually might be there more so than what the agent eventually replies back as their experience.
The obvious solution will be to use vision language models, right?
Yeah, so we started the project in 2023. There weren't real VLMs at the time, so I actually had to craft and using Meta's algorithm to kind of craft segmentation of each of the images, and then translate that into text through classes, and then tell the model, hey, on the upper left side there is a tree, on the bottom right side there is a road, and created that bottleneck, which I threw to the trash before the paper came out, because of course there are better VLMs right now that can do it. Even then, the translation of a visual three-dimensional environment to text for the agent to have that conversation is still text to text. So it's an image to text. And when we do that process, I think we're losing something down the road. And in the pre-conversation, we mentioned some of the work that is being done today about world models, and Feifei Li from Stanford, she's talking a lot about the fact that the text, that language is such a way of communicating the world. And so I think for us, there is a critical gap there in how we communicate a real world environment through language in a way that is not completely skewed and biased.
Yeah, I agree. I think like we talked about it in some of our previous episodes that from one hand, vision and images and videos are much more rich input, if you want. Like you have so many details and you can use these details. You have also some robustness to different details, and you have some overlap and things like that. Probably it's really good to use them in order to understand our environment, okay, interact in our environment. But from other hand, speech and text is some kind of a point to the human behavior or the human thoughts, right? Like we can use them in order to understand how humans think. And we need it, right, if we want to actually simulate behavior and simulate how humans behave in the world. So in some sense, you need both, and I think this is it's very interesting to try to simulate to use these two domains to something that integrate together.
Yeah, and earlier you had talked about some of the games with agents performing as like money, right? And give or take some money, Ravid. I'm also influenced by, there's a board game called Diplomacy, which relies quite heavily on, yeah, you guys might have heard of it. There was a lot of like AI research, I think even before the ChatGPT era, around making good diplomacy players. Now, I'm pretty scared of today's AI systems on games like that. I think that they're really good. So, I'm hoping that some of these principles can give us, going back to also like cars, like really accurate traffic simulation models, right? Because traffic is one of those things where the more I started like reading a little about it, I was having like that meme of like, what the heck? What the heck? Like nobody knows anything about this, right? Just similar to like turbulence, right? Where yeah, there's theory, but really, it's like you have to wind tunnel it. You just have to try it to understand how it's going to work in the real world. And maybe cars are a little too dependent in our society today, but they're here for a while, so we should figure that out, right? And I feel like really good digital simulations of them, as you guys have kind of discussed, is the way.
I think it's an excellent point. The field of mobility simulation, as I mentioned before, exists already for 6-7 decades. So we have, a certain degree of understanding of how vehicles move, at least in the large scale, maybe not super accurate in every street corner. But when it comes to humans, we know very little, if any. It's really a very new science about how people move, behave, react in the city. Big part of that is the fact that we didn't know where people are up until pretty much 2007. We have the first iPhone, which puts a tracking device in each one's pocket, and now we can basically understand where people are at large scale. And so different from cars where you can measure them at each street corner through some simple camera, people, you couldn't do the same. Suddenly we have these data sets. Suddenly we can understand where people are and what they potentially do. This still doesn't mean that we understand what they feel or react to in the built environment. So that was kind of a big part of the work that we're trying to do in this paper, try to better understand that. But I would say more generally, to your point, if 2023 was, I guess, the image moment for AI, and 2024 might have been the 3D video moment for AI. I think now we're in the world model of generation in AI. There is a growing conversation, at least on my feed, on people talking about. You've seen Genie, I guess, from Google, the presentation of a few weeks ago. I mentioned Fei Li from Stanford is building her own world models. I think we're starting to see this idea of a model that generates not just two-dimensional videos or images or even three-dimensional models, but something that has a degree of interaction within it that really allows you to move, to interact with whatever it is exist in that environment and report in a very human like way back to the model, so new things might emerge. You've all seen probably the video from Genie where somebody's taking a taking paint and a bucket and just starting to paint the wall, and this whole physical reaction is quite convincing. I don't know how physically accurate it is, but it looks very real. Or walk on the grass, or walk in a pond, and you see the legs kind of creating the steps. So all of that, I think, might be maybe a proxy to what you were referring to, Alan. A very good digital replica of the city that goes beyond just, how cars move or how much energy building consume, to really to the point of what it means to walk a street and feel the street and sense it and listen to the voices and to the sounds and feel the wall, and if it's hot or cold, or if it's there is too much sun, so I need to jump back into the under the tree. All of those small sensations we experience every day in the street, but up until today, we're not part of those simulations.
Do you think so? In your work, you somehow combine two things, right? One is like the physical aspects, okay? That how can, like, I don't know, if a person walk from here to there, or a car is going from here to the other street, so how does it look like, and what is the physical behavior of it, right? And this is, let's assume that world models like the recent, I don't know, Genie will solve it soon. But there is another aspect of how human will behave, right?
Yeah.
And do you think so? Let's assume that we don't know exactly how to formalize and how to actually simulate it in a good way. Do you think the first thing is also valuable by itself?
I think so, yeah. Because even if we don't know how to simulate well the experience of people in the built environment and have them as sort of thinking agents, just by simulating the city in high quality is already a good proxy to how we might, experience it. So even if we, just as humans, as designers, planners, or even the general public, have an access to how this street might look like, but not how it might look like in a perfected, meticulously crafted architectural rendering, or those kind of marketing drafts that they put on street corners to convince you that this project is going to be amazing, but eventually when it's built, it's horrible. Really sensing it, really walking through those streets as if we are part of that neighborhood, to me would definitely elevate the degree of conversation, the quality of conversation about future environment. And as soon as you can introduce into those simulations, for example, Alan, you mentioned traffic, so introduce bikes, virtual bikes that run through those streets, but they are virtual in a very high quality, right? Somebody sometimes fall and they didn't stop in red light, and they did stop in red light, and there are cars and there are other objects, and I walk through that street. What does this street look like? I think that, as a planner, as an architect, I would see that as a very, very beneficial step forward.
Good. Yeah, the world needs more people who are really thinking about these problems the way you are. Because, as I got older, I started to realize that the design and even the aesthetics of the things around me, the physical world, is profound in how it, changes our lives and shapes everything else. And so I started to see architects as urban planners, as really, so in some ways like the Sim City, like I guess whoever you play as, the mayor, I guess, right?
Yeah, well, I did not mention that at the beginning, but a big part of those modeling and simulation platforms we build, we actually build as physical models. So, again, this is an auditory medium, but if we were to show your audience what it look like, we build three-dimensional Lego models of cities and then project all of these analysis and visualizations on top of them. And so you can literally play physical SimCity in our lab and see, what happens when you add a building or remove a building or increase the size of the road and how many more vehicles potentially might go through there, the energy, the mobility, etc. To that point now, I think it's critical for us to adopt ways to communicate and to share these ideas. So beyond the analysis itself, beyond the science and the data behind that, how do you make sure that everybody that is around the table truly understand the impacts of those changes? And what we've seen time and again is that even the decision makers themselves, the stakeholders, the people who are supposed to kind of be, on top of that, have such a hard time really understanding what it means to change something, to adopt something, to build something in the street. And so the democratization of the process, I think, is a critical step forward in improving our built environment.
And do you think like it will be I don't know, a critical tool in the future, or like it will impact the decision? For example, there was a lot of attention for public sharing, and like to get the public involved in decisions and urban decisions in the neighborhood and things like that. And it looks, at least to me, right? Maybe correct me if I'm wrong, that it wasn't such a great success. Like at the end, like the plans are not better because we share them before with the publics and with the neighborhoods. So do you think it will change it? Do you think like there is some fundamental difference?
I'll answer in two layers. One is specifically about the tool that we've been talking about, the paper. I imagine, a designer sits in front of their CAD, computer-aided design tool, AutoCAD, or any of the tools that architects and planners are using, and they have a bunch of tools in the toolbar. And one of them is a ruler, and the other one is a pen, and maybe one of them is travel agent, where when they draft their next building or draft their next built environment, park or plaza, they also run that simulation in parallel and suddenly get, maybe in 2 years, 10,000 or 100,000 agents with different demographics walking through their design and reporting back saying, I feel uncomfortable. This is too steep. This is, not how I would imagine this park to be. And starting to have, on their shoulders, helping them understand better how they potentially should design that environment. So that's really kind of in the small scale of that tool. I think in the larger aspect, I actually see quite a lot of success in engaging the general public using different technologies and different tools, and not necessarily visual tools, just the fact that you can track conversations and see the sentiment of neighborhoods and of communities about their environment, I think already excels decision making in the city. We know of a few companies. There's a company here in New York called Zen City who is doing exactly that. They scrape and kind of go through the entire social media and a lot of other information that lives online, and then give kind of a dashboard to decision makers in cities to better understand, where the trash is not being collected, what is the congestion challenges that are currently facing. There are other companies doing, different types of similar work in terms of communicating better changes to the built environment. So tracking projects, bringing communities together to better understand it. Of course, there is social media, which became a huge vehicle to have these conversations. That's not to say that we can resolve every challenge with urban development and architecture, but I think that the process became much more transparent today. It's not possible anymore. We're in New York, so New York is a city that had decades of people kind of bombarding, parachuting huge projects without asking anyone for anything. And suddenly you see the cranes and you see the bulldozers and you see kind of a new highway, elevated highway where I live. A lot of those kind of top-down decisions. I don't think we're there anymore. I think there is a lot of scrutiny, there is a lot of openness and transparency in the process. But going back to our early conversation, sometimes too much. And so it's a question of balance. How do you make sure that you're not curbing any type of development, but at the same time keeping it open and transparent? I think technology has a room there to mitigate that gap, to, in one end, communicate, but at the same time, make sure that processes are not being stalled or slowed down to the point where we cannot build anything.
And what about biases? Like we talked a bit about it, but you don't afraid that, I don't know, now I'm designing a neighborhood and if like the AI will tell me that if there will be a poor people there, it will be more dirty or more stress, something like that. You don't afraid that we will replicate the biases that we have or like replicate the biases that we are trying to learn?
I recently heard a term called STP, the same 10 people. That's usually the amount of people you have in every community meeting that have time on Tuesday afternoon to come and shout about the next project that is being built in their neighborhood. And so when we talk about bias in cities, we need to understand that this is the baseline. You have the same 10 people that usually are the ones blocking any new development. From there on, you can only improve, right? If you get 100 people, 1,000 people, or 1,000,000 people, that's already, I think, better. That doesn't mean that there wouldn't be, of course, bias in the tools, in the AI tools. I think it's on us to, first of all, make sure that the tools, the models are trained in a proper way on proper data, etc. The Reddit comments might not be the best source of your community engagement efforts, and so we need to be a bit more cautious in that sense. But at the same time, and I think that's more generally about involving AI in the process of design and decision making, as long as you're keeping humans in the center, not human in the loop, human in the center, meaning humans as the decision makers, and you use technological tools, AI or not, as a support system for that process, then I think we're still in the right place. So even if the AI is biased, and even if other tools might be biased, at the end of the day, the decision is made by humans, and therefore the AI has its own spot. If, on the other hand, you substitute humans for AI decisions, I think that this is where you might start to see those biases becoming risky and dangerous in cities. And I will just tap back to that CAD tool that I mentioned before, the computer-aided design tool. You have a ruler, right? But the ruler doesn't draw the line. It just helps you to keep your hand straight and kind of draw straight lines. The same way AI models should not direct your drafting of the line. It can help you keep the line straight, but as soon as you substitute yourself, as soon as you lose your agency on the design process, on the decision-making process, then I think you're in a risky environment.
Hey, I think. Oh, I have one more question. I think maybe you can share with us. What is the MIT Media Lab? I think it's very interesting experiment and quite a unique lab in the field, right?
When I joined, the term that people were using to describe the lab for me is the biggest playground in the Eastern Coast, and adults playground, and it is to some degree a playground. We have, I think 20 something, 25, 26 research labs which are completely different from one another, and the only compounding element there is that they couldn't fit in any traditional discipline within MIT. So MIT has those, traditional schools, physics, computer science, chemistry, etc. None of those schools could adopt a lab that is both doing, urban design plus cryptocurrency plus robotics plus autonomous vehicles and psychology at the same time, which is, at some point was the form of our lab. And so I think what the Media Lab is doing wonderfully is really bringing people together. The hand-wavy term is anti-disciplinary approach instead of interdisciplinary approach. And I always try to explain that interdisciplinary approach is where you bring experts from different fields to solve a specific problem you have because you need those domains. Anti is where you don't have a problem. You just put them in a room and you let them come up with issues and come up with potential solutions afterwards. And I've seen that time and again where you just throw many different from many different backgrounds into the same room and interesting things coming together. I mentioned those city Lego models. I don't think that will happen in a traditional urban design or urban planning school for whatever reasons, but somebody just from I think it was a computer science came and say, yeah, let's just build it out of Lego. And so we built it out of Lego, and that became kind of a whole research field by itself. And so I think that's kind of the magic of the Media Lab, the ability to bring people from different backgrounds and let them kind of play together.
And do you think that or do you feel that this is something that actually works? Because there are a lot of places that are trying to make this, to bring together people from different fields and that they will sit and think about shared ideas. Why do you think it works in this case?
The Media Lab is celebrating 40 this year. So in 1985, there weren't many. So I think at the time that was I think, kind of a revolutionary idea of breaking the silos between the different departments, the different disciplines, academic disciplines, and kind of bringing people together. I'm totally in agreement today that you would go, even into companies, not necessarily academia, and you would find similar labs that are bringing people from many, many different locations and backgrounds and putting them together to make something new and interesting. I would say, however, that a big part of my work, which we haven't talked about, is deploying our research in different parts of the world. Because cities are such a kind of a tangible, applied type of science, we don't do just research for the lab. We try to put it out there. And we do that through a network of city science labs that we have started about 10 years ago. And now we have about 12 different labs from Southeast Asia to South America, where in each one of them we deploy these technologies and let them use for whatever purposes they have. What I see in those places is that they're in dire need for that interdisciplinary, antidisciplinary way of thinking, because they are, in many cases, still stuck in those traditional old processes and require, out of the box thinking for their challenges. And I think that in that sense, the spirit of a place like the Media Lab is truly helpful.
Very cool.
Come
Okay.
visit.
Yeah, I will.
Love for you.
Yeah, we could talk all day with you, Ariel.
Yeah, but I think like we are out of time. Anything else that you want to say, Ariel? Something that you want to promote? Anything?
Well, as I mentioned before, I don't have a SoundCloud, so I'll just say, generally that I would love for people to get more engaged in these big questions and big challenges that we're facing today. There's upcoming elections in New York. There is, a lot of conversation now, as I mentioned before, between the East Coast and the West Coast of how we can improve our cities. And the one thing people really need to understand is that they do have power. They have much more power and much more agency than they used to have before. There is so much more data out there. There is so much more collective, I think, energy to change things and to become part of things that really everyone in every neighborhood can have an impact. And so the more people can take place in that process, I think the better our built environment might be.
I totally agree. And with this optimistic
We have to.
message, I think, yeah, we will finish with this great message. Thank you, Ariel, that you join us. Thank you, Ellen.
You guys,
Always a pleasure.
See you next time.
thanks.
Bye.